Hey guys, I just want to do a couple of review problems for you. Hopefully you're thinking about that today. We are going to meet in the morning at 8:30, so I can answer a few questions, and then you can take your test online. I'm still working on how to get that to you, so that's one reason why it's not posting today. So I want to show you. I posted this on Remind. So these are just some conversions that if you will refer to those, then that will help you not make an error, right, when you're trying to decide how big, who's big and who's little, right? That'll keep that from messing up. So that was there. Also, Davey asked me to remind you of this is a middle school math hack, right? So when you have something like a density problem, that where you can rearrange the algebra, so density equals mass over volume, right? So you can put that into a triangle like this, and now it does matter where the letters are, right? So if you're solving for density, you cover that up, and it shows you that you are dividing the mass divided by the volume. I realize there's a delay on my camera. If you're solving for mass, then it's volume times density. And if you're solving for volume, then it's mass divided by the density. Okay, so you can, jot that down, and that's called like a magic triangle to help you work through that math. Okay, all right. I want to work two conversion problems for you, two-dimensional analysis problems. So if you want to do some conversion problems, I would recommend that you go to number 80 on page 63. You can work through those problems there, those conversions that will help you know. And if you want to upload, you can shoot me a picture of that on Remind, or you can add it in just the stream in the comments. I'll even put a note that said, do you have any questions? You could post a comment. I don't know if you can post pictures there. Maybe I'll just put a Google thing so you can upload stuff if you need to there. Okay, so you can do that. Let's do number 82. Okay, because number 82 has us do a dimensional analysis. So I'm going to write down what this problem is telling me so I'll know what I have to work with. Okay, so this says the average mass of a kernel of popcorn. So one kernel is 0.125 grams. I could have also written that as equals, but that's a conversion, right? I could also have this on the numerator and that in the denominator. And then it says if, so this is true. So 1 pound is 16 ounces. Okay, so that's another fact. And then the other fact is 1 ounce equals 28.3 grams. Okay, so that's all data. That's all information that the problem has given us. Now here's the question. How many kernels are in a half a pound? Now, when I have noted this, right? That's a really sad marker. Sorry about that. When I've noted this, now I know what word I need to end with. Kernels, number of kernels, has to be my last word, right? And then I also know what I have to start with, because that's the information. That's not a conversion information. That's what I actually have. Okay, so our math will start with 0.500 pounds. And now we look up here at the information we've been given. Where is a pound? Oh, right here. Right, so I want pound to go away. So I'm going to put pound on the bottom and ounce on the top. and I'm going to put the information 1 pound, 16 ounces. So you see how I'm using that? So that gets rid of pound. Now I have ounces, but I don't want ounces, right? I want kernels. So now I'm going to say, oh, well, kernel, oh, I need this one, right? We need this one. So now I'm going to put ounce on the bottom and gram on the top. And this is 1 ounce, and this is 28.3 grams. Okay. All right, so ounce cancels. Now I've got grams. Oh, now I have grams and kernel. So let's put that 1 kernel is 0.125 grams. Now gram cancels, right? Now I can put down my my pencil, and I'm ready to pick up my calculator. Now, here's the thing. If you hate your graphing calculator, I'm going to show you. Remember that you have a scientific calculator in your phone. Okay? I went to Instagram. It's automatic. Right? Go to calculator. Turn it sideways. My calculator's being sad. Why is my calculator not doing that? Oh, there it is. Okay. All right. Now, for this problem, you don't need the EE button, right? But I was just trying to remind you that there is an EE button here for this. It's right here. So that can be your times 10. So you can use your phone calculator if you don't have another one, okay? So there's probably one you can access online too. So you can get that. All right. Let me get this out of the way because we just need a regular calculator. So 0.5 times 16 times 28.3. This is in the basement, so it's downstairs, divided by 0.125 equals. All right, so now the number I got was 1,000. This is what my calculator says, 1,811.2 kernels. All right, so here's one of those things where we know, okay, well, I'm not gonna have a partial kernel, right? So now we have to round for proper sig figs. How many, so we don't care about these are our conversions. How many sig figs were here? 1, final 0, sandwich, 3 sig figs. So this means I can have 3 sig figs in my answer, right? So I write this number. It's my first one. There's my second one. Second second sig fig. And then I look here. Do I write a 1 or does this round up? I'm going to say no, the 1 doesn't round that up. So it's be 1. But now I keep my placeholders correct, right? So 1,810 kernels would be the correct answer. Okay? So that's one example of how I read the problem, looked at my data that they were giving me, figured out what I need to know and what I had to start with. Okay? Another really good problem is you might look at 84. 84 is along the same lines. If you need number 83 is a little more complicated because we're changing 2 units there. So maybe you could take a look at 84 but 80 for straight up conversions. And this is another problem. Let me know if you need other examples. All right.